Now, when we are calculating the regulation is stated that it is the rise or fall of the secondary winding provided that the primary winding remains constant. So when we are disconnecting large loads in the secondary voltage is going to rise or fall. So that one is called a regulation, the rise or fall of the secondary winding while the primary remains constant. Now, to calculate the regulation of a transformer, the formula is going to be, the percentage regulation is going to be E2 minus V2 over E2. So now when we look at our diagram here, or any of our diagram, we did say that we're going to have V1, and then we're going to have E1 here, and then we're going to have E2 here, and then we're going to have V2 here. E2 and V2, they are not the same because of this impedance. So now we have to calculate the regulation using this formula. But when they used the calculation, our engineers did also some calculation, and then I'm not going to derive those questions, those formulas, but we can also use formulas like this. We can use a formula, a percentage regulation, it's equal to V1 bracket RE1 cos theta plus XE1 sin theta all over, so here is I1, all over V1. So what you have to notice on this formula is that when we use E1, and when we use I1 and then V1, we have to use RE1 and XE1. And then when we refer to the secondary, it's going to be I2 RE2 cos theta plus XE2 sin theta all over V2. Okay, sorry if you cannot see that. Let me just write it again here. Open the space, gonna be IE2 RE2 cos theta plus XE2 sin theta bracket all over V2. So this difference here shows that we have referred to the secondary, we use I1, and secondary refer to the equivalent impedance, refer to the primary. Equivalent impedance refer to the secondary. So now we have to notice that we also use plus here. So we use plus because this is for a lagging power factor. If the load has a lagging power factor, we use plus. If the load has a leading power factor, okay, let me just, so we use because of a lagging power factor. If our load has a leading power factor, then the formula, a regulation, is going to be I1 RE1 cos theta minus XE1 sin theta all over V1. And then if we are referred to the secondary, it's going to be I2 RE2 cos theta minus XE2 sin theta all over V2. So this is the easiest formula that you can use to calculate the regulation. So first you have to calculate RE1 and XE1, and then you calculate the voltage I1 and V1 and I1. And if you have referred to the secondary, and then you can use RE1, RE2 and XE2. So if you didn't understand this or you don't understand this, please go back and rewatch the video. Please and rewatch the first clip of the video so that you get you understand what we're talking about here. So we are going to do examples at the end of the lessons. So now let's just finish. So now to calculate the terminal voltage V terminal, which is going to be the voltage that we get here at the terminal of our transformer. So to calculate that voltage, it's going to be V2 1 minus regulation, or we can say E2 1 minus regulation. We want to calculate the terminal voltage. So depending on some textbooks they say this is V2, then this is going to be E2 1 minus regulation. So it depends on the textbook, but when we are doing the example, we are going to understand what we are talking about here. So let's go ahead and do one example which is going to explain to us what we are talking about. Maybe we'll get the full idea of what we're talking about. Okay, now we are going to consider the example that is given on 3.1. So it states that a 200 kVA single-phase transformer has 600 turns on the primary winding and 120 turns on the secondary winding. The primary and the secondary resistance are 0.35 and 0.02. The corresponding leakage reactance are 1.4 ohms and 0.045 respectively. The supply voltage is 3.3 kilovolts. And we are asked to calculate the equivalent resistance and the reactance referred to the primary, the impedance referred to the secondary, and then we calculate the voltage regulation and the terminal voltage at the full load power factor of 0.8. So now we're gonna calculate first the the equivalent resistance referred to the primary. That's going to be Roman figure 1. So to get the resistance is going to be RE1, which is the equivalent. It's going to say it's R1 plus R2 N1 over N2 squared. Don't forget this squared here because your answer is going to be wrong. And then this is equal to 0.35 plus 0.02. The primary winding is 600 over the secondary winding is 120 squared. So this is going to give us 0.35 plus 0.02, 600 over 120 squared. This gives us 0.85 ohms. And then to calculate the equivalent resistance, impedance, and now to calculate the equivalent reactance referred to the primary, it's going to be X1 plus X2 N1 over N2. This is going to be 0, sorry, this is going to be 1.4 plus 0,045600 over 120 squared. 1.4, ne? .525 ohms. That means the equivalent impedance referred to the primary is going to be 0.85 plus J 2.525 ohms. If you don't understand the J notation, you can check the video here, which speaks about complex numbers. I explain complex numbers in detail, so you can just check the video so you can learn complex numbers, and then you can come back here. And then we can also change this to rectangular, which gives us 2.664 at an angle of 71,395 ohms. So now the regulation is going to be the same whether you are using the primary or the equivalent to the secondary. Whichever you prefer or you choose to use, you are going to get the same answer. So you just have to choose the one that is very simple. For example, here we are already given the primary voltage, so there is no need to calculate and use the impedance referred to the secondary, because now we will need to calculate the secondary voltage and calculate I2 as well. So the calculations are going to be more. So if we are only referring to the primary, it's going to be easy because we already have V1. So first, we know that the formula, if you check the formula, let's go and check the formula. Our formula, we are saying we are going to so our formula, the formula we are going to use, we know that it's this one. If you check your formula sheet, maybe it might be there, or you can just remember it. So we know that we need to have I1, V1, and RE1 and XE1, which you already have. Now we need to calculate what? I1. So to calculate I1, we know the formula is going to be S is equal to V1 I1. So it's a single phase, so it's going to be simple. Apparent power is the same in the secondary and primary. So it's going to be 200 times 10 to the power 3 is equal to voltage is 3.3 times 10 to the power 3 I1. Then we divide by 3.3 times 10 to the power 3, 3.3 times 10 to the power 3. I1 is equal to 60.606 amps. And then the power factor, they said it's 0.8. Therefore, theta is going to be second function, cos 0, and inverse of cos 0.8, which gives us 36.87 degrees lagging. They said it's lagging. So cos theta is equal to 0.8, and then sine theta is 36. Let's check. Sine 36.87 gives us 0.6. Now we are going to substitute. Then we said the formula for E regulation is I1 RE1 cos theta plus, since it's lagging power factor, XE1 sine theta all over V1. So I1 is 60.606. RE1, what's RE1? Okay, we've already calculated, so it's going to be RE1, it's 0.85, and then cos theta is equal to 0.8, plus XE1 is 2.525, plus sine theta, it's 0.6, all over V1 is 3.3 times 10 to the power 3. So let's punch this. So this gives me 0.040 if I'm rounding off to 3 decimal places per unit. Okay, so this is just how you calculate the regulation. So now to calculate the terminal voltage, it's going to be very simple. To calculate the terminal voltage, to calculate the terminal voltage, it's going to be simple. After you've calculated the regulation, now everything is just complete. I've calculated the regulation. As you can see, this is how you calculate the regulation. If maybe you didn't understand how we calculated all this, you can just go back, reverse, and then you check the video again. Okay, and now to calculate the terminal voltage VT, we said VT is going to be E2 1 minus regulation. So remember, on that formula we are given V1, but we don't have E2 or V2. So to calculate E2, remember when we are using this, we said if we have E1, we're going to use a transformer ratio here to calculate what? E2. We use the transformer ratio. So now to calculate, it's going to be E1 over E2 is equal to N1 over N2. So we have E1, which is 3 over E2, and then N1 is 600 over 120, and then we calculate E2 here, which is going to give us which gives us 660 volts, and then V, the terminal is going to, now we are going to substitute 660 1 minus 0.04. It's 600 bracket 1 minus 0.04. This gives us 576 volts. So the voltage is 576 volts. Okay, this is basically how you calculate the voltage regulation of a transformer. So I've tried to explain everything. This covers almost everything related to calculating the terminal of your transformer. So please don't forget to hit the subscription button and the bell icon so that you get notified every time we upload videos which are going to help you pass your exams. So now we are going to calculate the efficiency, the maximum efficiency, the efficiency at a certain percentage of operation of a transformer. We are going to learn that on the next video. Thank you and enjoy your day.